whereas this function, for example, would be considered decreasing. But it brings up an interesting question. Is this function increasing or decreasing? Call it g. Well, it's not an increasing function, and it's not a decreasing function. Not in its totality anyways. So maybe the better question is, where is the function increasing, and where is this function decreasing? We'll put in some grid lines to get a better look. We'll start with the question of increasing. Before I give an answer to this, I have a yes or no question to ponder here. For the x values 1 through 3 on the interval from x equals 1 to x equals 3, yes or no, is this function increasing? Well, as you can see, on the interval from 1 to 3, it is an increasing function. So if you were asked, where is this function increasing? And you said from 1 to 3, as we did in interval notation in this question, you wouldn't be wrong, but you wouldn't be telling the whole story, because this function is increasing in a bigger interval than just from 1 to 3. So while we could say yes to this question, let's see if we can expand the section in which this function is increasing. When we're asked where is a function increasing, we're expected to list the largest possible interval or intervals in which it's increasing. And if you look at the graph, you can see that this function is actually increasing on the interval from 1 to 5. And that would be a better answer. If you were not using interval notation, you could use something like this. But typically, if you're in one of my classes, we'll use interval notation. It's worth noting that sometimes the question is asked, when is the function increasing? Which may sound like a time question, but actually means the same thing. It means for what x values. It's important to remember not to use y values in the answer to the question when or where is a function increasing. Okay, so let's move over to where is this function decreasing? Well, one place it's decreasing, as you can see here, is in the leftmost portion of the function. This tends to confuse people because it includes an up arrow. An up arrow tends to make people think of things increasing. But remember, that up arrow just means that the graph goes on forever in an upward and leftward fashion. But if we're reading the graph from left to right, as we read graphs, then that is actually a decreasing portion of this function. And since the x-axis goes on forever to the left, we could say it's decreasing from negative infinity through 1. But you'll notice by looking at the far right side of the graph that that's not the only place this function is decreasing in a left to right reading. The function is also decreasing starting at x equals 5 and going forever rightward. And since the number line goes on forever to the right, we use the infinity symbol to represent that this function is decreasing from 5 through infinity. And you'll notice that there are two separate disconnected places where the function is decreasing. When that happens, we tend to put a union symbol, which looks like a capital U but technically isn't, in between those to indicate that there are two places where the function is decreasing. Remember, you might hear the word where, or you can also list it in inequality notation, which we won't do in my class. You might hear the word where, but you might also hear the word when. And while where and when seem like much different words, after all, where is somewhat of a location and when sort of implies time. But in mathematics, when we talk about functions, where and when are often used interchangeably to ask for x values. So again, it's important to remember not to use any of the y values when answering where and when questions about a function. Let's talk about what extrema are. Here's a function, and we'll call it h just to give it a name. An extreme point is either a maximum or a minimum. Extrema, maxima, and minima, all these words that end in A, that's just Latin pluralization for these words. So when you see a word ending in A here, it's just talking about more than one. Okay, let's talk about a local maximum first and what it means to be a local maximum. It's not surprising that a local maximum would be a point with the highest possible y-coordinate, but that's compared to any points nearby. And what does it mean to be nearby mathematically? That doesn't sound very precise. Well, once you get to calculus, they will give you a precise definition of what nearby means. You'll notice these three red dots are all maximum points in the sense that they're all higher than any point nearby them. That makes them a local maximum. A local maximum is also sometimes referred to as a relative maximum. Here's the calculus definition. This is very precise and it clears up what nearby means, but if you're in a pre-calculus class, you don't have to think about that yet. So let's just be a little bit more vague about saying that as long as a point is the highest point to any nearby point, then it is a local maximum. Again, sometimes referred to as a relative maximum. Let's look at the local minima of this function. A local minimum is a point whose y-coordinate is lower than any of the, quote, nearby points. Here's one, and notice on the far right side of this function, that's not an arrow, it's a dot, which means the function just goes on and stops there. That point is also a local minimum because it is lower than any of the nearby points. Local minima are often referred to as relative minima. Let's look at another kind of maximum called an absolute maximum. An absolute maximum is a point on a function for which there is no higher y value anywhere whatsoever on the function. Here's a definition. So for example, these 2 points are absolute maxima because we can say about either one of these that there is no point higher than that anywhere on the graph, not just locally, but in a broader sense anywhere. Absolute maxima are often called global maxima. We'll call them absolute maxima if you're in one of my courses. And finally, we'll look at the notion of an absolute minimum. You could guess what this is. It is a point for which there is no lower y-coordinate anywhere on the graph. So for example, if you look at this example, you'll notice there's an arrow. That arrow means that this graph goes forever down and forever left. And because it goes downward forever, there couldn't be a point for which there was no lower point. And since there's no lowest point on this graph, we say that there's no absolute minimum or no global minimum. It's worth noting that this particular point here is a local maximum and an absolute maximum. It's both. It's a local maximum because there is no point nearby with a higher y-coordinate. It's an absolute maximum because there's no point anywhere with a higher y-coordinate. Likewise, this point is also a local and an absolute maximum. Now, when it comes to questions about extrema, sometimes the wording really matters. Here's an example. If you were told to name the local maxima of this function, when you're asked to name them, then you're being told to list the coordinates of where they physically are. Remember, these are our 3 local maxima for this function. Pause if you need to see the numbers and verify. So if we're told to name them, then we list the coordinates. On the other hand, if we're asked when or where do they occur, then y values are not mentioned here, and you simply say at a certain x value. There's no doubt that these three red points are our local maxima, but how you answer depends on how you're asked. If you're asked to name them, then you list the coordinates. If you're asked where are they, or when do they occur, then we simply list the x values. Same goes for local minimum. This local minimum is at 0, this local minimum is at 4, 1, and likewise the last local minimum is at 8, -1. If you're asked to name them, then you name them by coordinate points as we would name any points. But again, if you're asked where are they or when do they occur, you simply list the x values. It's not enough to know how to find them. You need to know what's being asked of you. Let's look at the absolute maxima. As we know, here's an absolute maximum at 3, 4, and there's one at 5, 4. Where do they occur? We list the x values. Sometimes you'll be asked what, or to find the maximum of a function. When you're being asked what is the maximum of a function, you're being asked for the y-coordinate only. This function has a maximum of 4, and I'm not referring to either of the points that gave us that maximum. There are two places on this function where it attains a y value of 4, but we're just answering generally that this function has a maximum of 4 because there are points that have a y-coordinate of 4, and there are no points that go any higher than that. So again, to recap, if you're asked where or when, you list x coordinates. If you're asked what the maximum is, you only list the y-coordinate, or if you're asked to find one. And if you're asked to name them, you list the coordinates. Let's name the absolute minima of h of x. Well, it doesn't have one, so there's nothing to name.